Good afternoon, friends. So there is going to be a change of track. No more buildings for the next 20 minutes or half an hour or whatever time they give me. We are going to talk about some other types of structures where steel is also made some significant mark. These are bridges and other types of special structures. Of course, there are far too many, but I will try to give an exposure of some of the projects that we have been involved in. I want to talk about composite steel concrete construction, how this is used in bridges. Something about truss bridges and pedestrian arch bridges, and finally the most important and least known advantage of steel is the temporary constructions. You cannot think of any other material other than steel for these type of temporary constructions. Okay, first one, what you see here, I'm not going to use this because otherwise people can see only one of them. So I'll use the arrow here. This is the deck on which the traffic moves. It can be a metro, it can be a highway road or anything like that. And you have the steel structure below. And connecting these two are shear studs, these little things that you see here. This is the heart of the composite construction. This makes sure that both the materials and both the components act in a composite fashion. So you are using the strength of concrete in compression, and you are using the strength of steel in tension, and both of them are acting in unison. That is what composite construction is. This particular project is, this is what it looks like, the shear studs at the interface between the steel and concrete, which makes sure that they work together. And you normally pour a cast in situ concrete. This cannot be done by putting a precast concrete connection, but wherever the connection takes place, it has to be cast in situ so that there is a proper bonding between the two. The project that I am going to talk about is the Mukarba Chowk, which is on the outskirts of Delhi, and that's where all the buses start from, and that's where people alight whenever they come from outside, particularly from the north from Chandigarh and so on. This is where all this happens. So this is the flyover, and you have a clover leaf junction, as you can see here. Most of it is above ground, well, not most, but some of it is above ground, elevated that is, and some of it is on ground. We always try to reduce whatever is elevated to reduce the costs of the structure. There is no use making everything elevated when you can go work on the ground itself. But there are many places. For example, here you got a water body. So water body, although this could have been done on ground, but you can't do that because there is a water body, so you have to span across that. What you see here is a very interesting feature which the authorities wanted. A bus stop right at the top of the flyover, at the highest point. And this is very easy to say, but easy to construct perhaps, easy to design, but to make sure that people are able to use this. Sometimes people get off the bus here and they have to take a bus in the opposite direction. So how do they cross this? So the planning of all this was a very major issue. And of course, this is perhaps the first time you see these small things where so much care has been taken to segregate the traffic, like pedestrians, cyclists. So they all have a different route altogether and they don't interfere with each other. It is a continuous box girder in steel. There are very few of them in India. I don't know whether there is any other or not, but this is certainly one of them. Here you can see how a steel girder of a certain length, this is the the U part, and above this will be the deck slab which is going to be cast in concrete, and then there will be the composite action. So first you put the steel part in position. Here you can see it's a huge carriageway, 14 meters wide in each carriageway. It's about 28 meters of it of the carriageway at the top to be put. So we have separated it into two parts because this would otherwise be too wide to do it. The steel box you can see here, and you can see the concrete slab at the top, and the two are composite. When you come to the bus stop, what we have done is that instead of having two boxes, we have increased it to 3 boxes, what you see here. The center line of course is somewhere here of the flyover, and you will get another 3 boxes on the other side. So to increase the width of the flyover at the top without changing the method of construction, this is the technique which was adopted. The final shape and view of the flyover is here, and you can see that there is very little difference between a steel flyover and a concrete flyover as far as the visuals are concerned. You can make it look exactly like a flyover in concrete, and nobody will be able to make out. Of course, you have to paint it to make sure that it doesn't corrode, unless you are using stainless steel. I think my friend Mr. Suri has gone away. He's always talking about stainless steel, but anyway, stainless steel is too costly for this type of a situation, but these type of things have to be done. And I think that in one of the issues mentioned in the last presentation, you have to worry about the fireproofing, and this steel definitely is not, you cannot have an exposed steel. It is not fireproof, or it has very little fireproofing. You have to, composite construction, what was used by Mr. Gera, for example, in this type of a situation, is an excellent example how you can not only make something composite, but you can also make it fireproof, or at least of the same fire rating as concrete structure. So that was a very good idea, and that's outside the structure may look like concrete. Inside, when you go into the boxes, it is more complicated, and this is what it looks like, because you got a thin skin which has to be stiffened all over the place, and this is what the inside of it looks like. But this of course people don't see, so you are not bothered about it. The shear studs, there are special machines as to how to weld them onto the top of the girder. It is not welding by a welding rod or something. These are special welding machines, and they are portable. You can do it at the site, or you can do it at the factory as you like, as you can see here. The connections are highly complicated. You can transport, for example, like it was also mentioned in the earlier on, the fabrication facilities, steel fabrication facilities are very few in India, at least when you start talking about bridge standard specific fabrication, which is very, very stringent. It is much more stringent than buildings. So you have to do it in a proper fabrication yard, which may be situated, in this case for example, it was located some 350 kilometers away, and then you have to transport it in small segments which are transportable. You bring it to the site, and then you have to splice them, and this is how the splicing has been done. You can see how close these bolts are. This you can do if you use high strength friction grip bolts, and that is what the technology is of today. We don't do riveting, we don't do bolting of any type. Even high tensile steel bolts are of not much use. You have to start using high strength friction grip bolts, which are a little different from, you have, of course these are high tensile steel bolts, but they are high strength friction grip bolts, which you can put them as close as possible as you can see them here. Okay, let's talk about something else. Steel trusses, this is a 600-ton truss, and the question is that how did, this is over the Raja Garden flyover, how was this put in position? 60-meter span. First it was assembled on the outside, this because this is, you cannot start assembling it on top of the Raja Garden flyover, and there was another one which is over the railway tracks, and this as a matter of fact is over the railway tracks, which I will just show you what it looks like. So you can see how these splices are there. These things have come from Calcutta because we could not find any suitable agency at that time, this was about 5-6 years ago, who could do fabrication of bridge quality fabrication, I would call it. So a lot of it had to be transported from BBJ Calcutta and then assembled, and then the best part was how to launch it in position. I will show you how it was launched in, these are railway tracks, very similar structure. There were two separate trusses. What you saw was the Raja Garden flyover truss. This is over the Kirti Nagar railway tracks. So you can see how it is being pushed into position. Here it is already pushed and no sort of supports are required. Railways are very possessive about their right of way, and you cannot put anything inside that. So you require normally long spans, and 60 meters is not unusual. So this is how you push it in position, and here it has gone back. The whole bridge is now in position, and you can see that it is without any supports or anything within the right of way. Let's talk about pedestrian arch bridges. This is what a pedestrian arch bridge looks like. Well, this is what an arch bridge looks like, and the best part of this arch bridge is that you can have long spans and you can put the supports outside the carriageway. This is what required from the point of view of safety. If you look at these are some of the footbridges which one has seen in Delhi, which is very unfortunate that you have traffic moving just next to it, and you got the central verge is supporting the footbridge. What will happen if there is if this thing crashes against the this column or pier? It will be a disaster. Anybody is walking like these would be most unfortunate people who are walking on the footbridge at that time. So it is extremely important to understand that most of the footbridges in Delhi are not as per the Indian Roads Congress codes. The Indian Roads Congress tells you as to if you are within a certain distance of the carriageway, what are the forces for which you have to design these supports in the horizontal, in the transverse direction, in the longitudinal direction, and so on. And believe me, what you saw in the previous slide, those type of bridges are not designed to take these type of forces. If you really design those for the forces which are given in the Indian Roads Congress code, then this is what it will look like. And this is what we have done, for example, in the Delhi-Gurgaon Expressway, where people didn't want an arch bridge or anything like that. They said, no, you can use the central support and all that. So anyway, we did all that, but this is what it looks like. It requires a concrete pedestal which is fairly high, and it requires a huge support. This is not the prettiest sights to see, but an arch bridge, it is aesthetic by its very form. The completed pedestrian bridges, now there are 7 or 8 of them, I think, in Delhi, which have been constructed, starting from the Commonwealth Games. And you can see this is really all aesthetics basically, and you are keeping all the supports away from the roadway. There is no central, no support on the central verge, which is what you require. Let's talk about temporary construction. This, I think, is the most useful part of steel when you look at it from the overall point of view. Of course, steel structures can be made, but what about the concrete structures? Even the concrete structures require require steel before they can be constructed. I will give you some examples. Many of these bridges would be impossible to construct if it were not for steel. Here you see a underground station which is being constructed, and you see next to it are all these government buildings. This is typically 20 meters or 22 meters below ground. You can see the size of people here, and then you will be able to imagine where this is. Now the question is that how to make the sides stable, which is a combination of geotechnical engineering and structural engineering. Both have to come together before you can decide how to stabilize the sides. And of course, these rolling stock that you see, this is bringing the soil from the tunnel which is being constructed beyond this. The railway tunnels, you must have seen the metro tunnels which are circular in cross section. So when you are digging through that, the soil has to be brought out, and this is what this rolling stock is meant for. So this is another railway system which has to be designed, and to take it out, and then how to take out the muck, which is huge in quantities, that is an exercise by itself. But coming back to the steel structures, you got all these, maybe they can lift about some of them 300 tons, 400 tons gantries which are there, which move over another temporary structure which is somewhere here. I mean, these type of loadings and all that we are talking about, and the size of the steel members is something huge. You can't think of them in steel buildings. You are there, it is just minor things. Here it's huge. The general thing that we try to do is that you got this narrow slit. Typically a station building is about 250 meters long and it's about 25 meters wide, and the earth pressures which are coming from both sides, they are neutralized by putting a strut in between, so that from the earth pressure from one side and the other from the other side are neutralized by just connecting these two. This is the typical strut which I have been talking about, and of course you require some timber lagging, what we call, these are all in timber, which are put in steel soldiers. The idea is that you should not get debris falling inside. For that you require all this, but really speaking, it is the strut, and what is the veiler? This veiler is actually another steel member which is spanning across all these soldiers, if you can see these. So this is how we try to do it. This is some fascinating thing, and of course you also have further stability if it is required by putting in pre-stressed anchors which go deep into the soil. Let's talk about another one, staging to cast this concrete, and what it looked like is something here. You see this? This is 25 meters tall scaffolding. How would this be done if it were not for steel? This can never be constructed. Let's talk about another one which is in Delhi itself. This is the Delhi Gurgaon Expressway, which has got this very sharp curve which goes to the Indira Gandhi International Airport. Now the question was how to construct this. It was not possible to do it in the other types of construction. The rest of the many kilometers of it is all in pre-tensioned, precast concrete girders, but this part couldn't be done in that fashion. So if this has to be done in cast in situ and you don't want to stop the traffic, then what do? What you do is this. That means that you make a through truss in steel, support it on the outside, and inside this you put the shuttering and do the concreting, which means that you have not disturbed your traffic on the Delhi-Gurgaon Expressway, which is in any case very famous for disrupting traffic and the lives of people in general. But anyway, this is how it was constructed, and I want to say that this type of a thing could never have been constructed if it was not for steel. And I think more engineering perhaps went into the design of this steel structure, the temporary steel truss, because it has to be designed from many considerations. You have to have, if you are doing it cast in situ, you must have people walking there also on the top. That means it has to be much wider than the width of the structure itself, what you are going to cast. So anyway, all these things come into the picture. The steel truss is straight, your structure has to be curved, which means that it has to outflank this whole structure. So it's a very wide temporary construction that you have to make, but this is how it was constructed. Another fantastic example, this is on the Delhi, on the Jammu Udampur rail link, where you have some 70-meter tall piers and you have about 102-meter span. This is typically, all such cantilever bridges are balanced cantilever bridges. They grow out like trees from the piers. As you can see from here, you grow out in this direction and you grow out in this direction. So long as it is balanced, it is very easy, you are not touching the ground. As you can see here, from here to here, no problem, from here to here, no problem. But the last part has to be constructed in situ, on staging. It may not be in situ, but at least on staging. The end spans are always larger than the central span for stability. They are often called the anchor spans. You don't want, if the live load is moving on the central span, you don't want any uplift in happening on at the end piers. So that is why the end spans always have to be larger, and typically they are all three span constructions. Now this one, to do it on staging, is one kind of a situation, and this has been done in many of the metro structures which you can see in Delhi. This particular one also, you can see how the end span. This is of course the flyover over which the metro bridge is going across. It is going half from this side, half from this side, and then meeting at the center and making a joint. But the end span has to be done, part of it on staging, which is being done here. This is another, I think, fairly intelligent conception we made, where it is not possible to have these tall, 70-meter tall temporary stagings. So a truss was made to be supported on this end of the balanced cantilever part and the pier, and this is all made cast in situ on that staging, on this temporary structure, without putting any staging from below. So even these type of constructions, they are possible only if you use steel. They are not possible just making it in concrete. Here's another fabulous idea which was used in this, beg your pardon. Okay. Anyway, you can see it here. These are full span precast girders, about 20 odd meter spans. They are made in a casting yard which is located at one end, and they are brought on trolleys up to this point. Then what you have is that there is a steel truss here. On this steel truss, the depth of the steel truss is the same as the depth of the concrete construction, so that the same girder which you have brought can be brought on top of this. Once you brought it on top of this, these are temporary again gantries, where you lift this girder up and take away the supporting truss from below. After this has been taken away, you can lower the span on top of the bearings, and then what you have to do is take away this sort of a fixed gantry and put it on this pier, and again bring another precast span, bring it here and then lift it and take away the truss. So it is so easy to do it, but all this, the magic is of the truss really. Bringing the girder here is not so great. I mean, you can put it on trolleys and bring it, but I think this is what the thing is. So there are many other types of construction, like for example, this is a very good example over the first metro bridge across Yamuna, which is by a technique called incremental launching. It's got a steel nose which is about 70% of the span length, and this little shed that you see here, this is where the whole thing is constructed, span by span. You make one span, attach the nose and push it forward, and you keep constructing at the rear and attaching more and more spans behind and pushing it. And when it cantilevers out between this pier and the next one, if it was concrete, then this whole construction would be impossible, because you cannot have a cantilever which is the same as the span of the which is the same as the simply supported or supported span. Then you are not designing for the service load, you are designing only for the construction load, and it will be extremely costly to do that. So this was again possible only because of this little piece of steel work which is attached by pre-stressing to the concrete structure, and this whole thing is pulled forward. This of course you must have seen in Delhi all over the place. There are many such launching girders or assembly trusses. You bring these precast segments, they are taken up and then they are joined together and pre-stressed and then placed on top of the bearings. I don't know whether this will work, but let's try. No, I think this also doesn't work. Okay. So anyway, this is another example of a steel truss where you have a gantry, a movable gantry which is moving on top. So you bring the segments here, precast segments, they are lifted by the gantry, put in position as you can see here. These are all segments, only 3 meters wide, and you level them, line and level them by these these yellow things that you see. These are actually hydraulic jacks, so they are all leveled and all that, and then you attach it to the already constructed portion, and then you move to the next span. So this is another way of where it was used. Anyway, I think my time is up, so I think I'll finish here. Thank you very much for your very patient hearing.